Okay, well, let's get started, everybody. Greetings, everyone. Thank you for joining us today. I hope that wherever you are, that you continue to be safe as we continue to attempt to turn to some level of normalcy. My name is John Avery. I'm from Bradmark Technologies, Marketing Director, and I'll be your moderator today for today's session. This is the last of our SAP ASE series. Today's session, the foundational technologies and optimizations for running SAP ASE on AWS Cloud. Let's go to our quickly to our agenda. We will be having Peter Thawley with us today presenting. Ed Stangler will also be joining us, and then we'll have a Q&A and wrap up. We're very excited to have Peter Thawley today joining us today. He's a champion of SAP. I know that ASE, I know that you probably have been with him, have seen a lot of his presentations in the past, and has seen him in person working with you guys on a lot of these technologies. He is the principal database solutions architect at AWS, and we will he has over 30 years of experience expanding across a wide range of diverse technologies. He's been obviously an early user of the SAP ASE community. He's built performance monitoring solutions at the very beginning, and so monitoring is very near and dear to his heart, and so it is ours, and which is why we have a very strong relationship here. He then went on to SAP, where he was chief technology advisor, and as well as working with many conferences and worldwide industry groups for as many years with SAP, and then obviously now currently is at AWS, and working with as a trusted advisor to many executives and engineers alike by mentoring on products and technologies, and as he continues to advance his technology and knowledge of cloud environments. So we will be moving forward. All attendees will be muted at the end of the session, and we'll be happy to have a Q&A at the end of the session. So feel free to provide your questions, and we'll be answering those at the end of the session. So without further ado, let's move on and have Peter present. And Peter, I will give you the floor.
Thank you all, and I hope everyone's having a good day. I see a lot of friendly names, some from way back. So again, thanks for the opportunity, John, and I'd also like to express my sincere hope you guys are all having fun, being safe, and enjoying what you're doing. So yeah, today I'm going to talk a little bit about AWS, right? Kind of a new topic for me. I've been here at AWS now not quite a year, and having a great time, but still have SAP ASE near and dear to my heart. So with that, I want to talk, hopefully this works, okay. Hang on one second, I seem to be having a minor malfunction. There we go, there we go. All right, so, I wanted to start off by just talking a little bit about migrating to cloud, right? Because obviously lots and lots of people are talking about it. There's a variety of sort of approaches, right, people take when they think about moving, application stacks and databases into especially a public cloud arena, right? And for the most part, what we see, especially for those companies that are enterprises that have, spent 10, 20, 30, 40, 50 years running their own data centers on-prem, right? Mainframes into client server, and now into cloud. The vast majority of enterprises are basically doing what we call lifting and shifting, right? They're basically taking their stack and they're moving it from their own data centers and putting it up into, a public cloud provider like Amazon or some of those other guys that I won't mention. And the reason they do that is really to gain experience, right? The cloud world is, as I'm learning, radically different than doing things on premise, right? On premise, things were a lot easier because you had these massive firewalls that very few people could penetrate through, and so security aspects were completely different, right? And just the whole model of monitoring and managing and deploying stuff is just radically different. So most people do this, and then what they'll often do is start to sort of expand around the edges, right? They'll look at integrating new cloud services into their existing stack, sort of in a piecemeal fashion, right? So really what I want to focus on is what is it that's in the AWS world that makes it really fascinating and cool to deploy a lot of the database workloads into them, right? So I want to start by talking a little bit about the sort of global infrastructure, right? It's pretty clear, at least to me, that the timing of most customers, not all, but most customers running their own data centers is dwindling, right? The big boys, right, and girls, pardon me, will be, obviously maintaining their infrastructure for some probably extended period of time. But what I hope you'll see at the end of this is that it's really not effective any longer, given the amount of investment that AWS and Google and Azure are making in their infrastructure to be able to run this stuff. So we're going to talk a little bit about these sort of 5 areas: regions, availabilities, availability zones, data centers, network, and some of the custom hardware that we're basically inventing, right? So the first important point to note is that we're everywhere. I mean, literally, AWS has data centers and availability zones everywhere, and it's growing, right? You can see from this picture that in the first 5 years of AWS's existence, we were in those blue regions, right? Northern California, Virginia, Ireland, and Singapore, right? Just 4. Then we added 7 in the next 5 years, and now in the last 4 years, we were up to 13 regions and 2 what we call local zones, and we're adding a few more pretty much every couple of years. You'll see this, right? So the point here is that no matter where your business needs to be, whether your headquarters is in Europe or the US or in Asia, or you just need to deploy systems closer to those end customers or business partners, it's pretty clear that the public cloud infrastructure guys are going to have a much better and more cost-effective model for you guys to deploy your awesome solutions in, right? So let's talk now about sort of the hardware side of this, right? So, and this is quite a bit different depending on which public cloud vendor you talk to, right? When we talk about a region is a geographically diverse area, right? It is an area that we have what we call multiple availability zones, right? And an availability zone is a sort of a first-class citizen in how you deploy, hardware and software, right? Even within an availability zone, depending on the size and location of customers in those areas, we might have 3 data centers, we might have 4. pretty soon, I know there's going to be some AZs that have 5 data centers in them. So you can start to see that the investment here is really, really significant, right? And the reason we do that is because we know that stuff fails, right? Things fail all the time. Servers fail, storage fails, and so for most of us, this is about building an environment that can offer, if you need it, the highest availability, the highest scalability, and fault tolerance. Okay. So a region, again, multiple availability zones. Typically, it's at least 3 availability zones, again, sometimes 4. And then within each AZ, there is multiple data centers, usually 3, sometimes more, that all have their own discrete and redundant power, networking, connectivity, right? The AZs are connected basically through high-speed links. And all the data centers within one AZ are encapsulated with metro fiber. So this is sort of our AZ design, right? They're meant to be separated by enough distance that if there was an earthquake here, odds are in Oregon, we're probably okay, right? Completely unique power infrastructure. Hundreds and hundreds and hundreds of thousands of servers, right? And within all of the data centers within one AZ, isolated metro fiber, and then AZs are connected through 100 gigabit backbone. So lots of capacity, lots of bandwidth, low latency when you need it, right? Okay, so networking really is the crux of a deployment on a public cloud, right? Everything communicates over the network. Storage is network attached, right? Instances communicate back and forth to each other. Even in more of a traditional, kind of client server oriented or deployment of a database, it is usually very critical to be thinking about network latency in your deployment, right? And so over the years, we've really spent a lot of time working on network latency, right? Back in the early days of AWS, right, it was just a gigabit network. Now we're basically at 100 gigabit worldwide, and there are ways in which you can ensure that traffic within your stacks can stay on the backbone as much as possible, stay on that 100 gigabit network, right? Most of the higher end instance types, what we'll talk a little bit about later, are capable of doing somewhere in the 4 to 4.5 million packets per second level at less than 50 microseconds latency, right, from point to point, between AZs. So ultra high throughput, ultra high bandwidth on the network side, right? We have redundant 100 gigabit basically in private capacity between every region around the world, right? So while we can't break the laws of physics with respect to latency going from the West Coast to the East Coast or from the East Coast to Frankfurt, we can do pretty good, right? We also have what we call these points of presence locations, which is where we have infrastructure that allows companies to have direct connections of their telco lines into the AWS infrastructure. So for the most security conscious people, there are ways basically that you would never have to communicate out through the public network, right, out through the public internet. You can pretty much tie everything up to go direct from your enterprise network and your enterprise telco lines into the AWS backbone, and then from there, from region to region, depending on where you're set up. So pretty cool. So how do we do all this, right? And a lot of people think that AWS is basically a a hardware and software company, and we are. But unlike some companies, we basically build our own stuff because the scale of the AWS world is pretty ginormous, right? We build our own routers, right? We don't buy anybody's routers. We build our own to be able to get the kind of performance and latency out of it that we need to. Same with load balancers. Same with compute and storage. Yeah, sure, we use ARM chips or Intel chips, but much of the construction of our instances and our storage are our own. We build our own semiconductors. I'll talk a little bit later about some purpose-built chips that we build specifically for performance and security. We have our own version of Linux that is running on our instances. Now, you can certainly use a Red Hat or a SUSE or somebody else's, but we also have our own. And we build our own hypervisor. So we have a hypervisor that's built off Xen originally, but both Linux and the hypervisor and basically all the hardware you see there, we've just stripped everything out that is general purpose and made it very specific to the AWS network, AWS environment, right? And that's why we do it, to squeak out as many cycles as we can from the hardware to basically run your stuff, better, faster, and cheaper. So processor-wise, most people deploy on Intel, but there's a lot of workloads that are starting to be GPU-based and use NVIDIA. So you can get these massive instances now with, thousands of GPU cores. We can deploy AMD. We also have our own processor that's it's an AMD-based design that we have come out with a little bit ago, maybe a year and a half, 2 years ago. Again, really just trying to drive the price points of compute down for people. In terms of instances, we now have about 275 different instances. And the interesting thing about this idea is that applications are all different, right? Some are memory bound, need high memory but low compute. Some are compute bound, right? Need high core counts but don't really use a lot of memory because they're whatever, web servers. Some need, super huge amounts of memory. Some need, high networking. Others not so much, right? So the point here is that no matter really what your workload is, we have instances that can really help you sort of fine tune the costs of running this stuff, in a cloud environment. For SAP, for HANA, for ASE, for IQ, we've got a variety of what we think of as kind of the normal instances we see in these workloads. The R5 series, the X1s, and some of the Z really super high memory configurations. So again, doesn't matter if you're deploying, scale out, BW, S/4HANA. There's lots of different options, both for scale up and scale out architectures for SAP, for ASE, and for IQ. On the storage side, we basically have 3 different types of storage. Most database workloads are going to use EBS, which is our block storage type. Most of the higher end ones used what we call a provisioned IOPS, which is an SSD-based approach. I'll talk a little bit more about that later. We also have, clustered file systems. So if you need to be able to have an elastic file system that spans instances across nodes, we have a solution for that. And of course, we've got the really low cost object store types, right? The S3 type capabilities. I'm going to talk more about EBS because from a database perspective, that's pretty much what people use for high-end database workloads. Right now, we can provision, basically we have a way in which you can provision performance in IO, right? And shockingly, we're doing, even in EBS, right? We're doing, upwards of 80,000 IOs per second. Again, across the network, which is insane, with basically single-digit millisecond latency. And there's some things we're going to talk a little bit about when we get into some of the details about how you can kind of minimize latency even further. But easy to use, right? You can provision it up or down if you need high performance for a few weeks during, some big peak period in your workload. You can scale up capacity on the IO and then scale it back down when maybe things kind of return to normal. Very high reliability. For the most part, all EBS volumes are replicated across data centers and within within a storage unit itself, obviously using RAID type technology. They're virtually unlimited in size. We have encryption techniques, and we can encrypt using customer keys. And again, it's pay as you go, so it's pretty cost effective, right? Now, most people, as I said, use provisioned IOPS. There's also a few other options for workloads that are more big data or analytics oriented that need consistent high throughput, but aren't really latency sensitive, or volumes that maybe you really don't need to access very frequently, and you don't need a lot of performance when you do. So lots of different options from a storage and performance perspective, right? And EBS is used kind of across the gamut, right? Whether it's relational databases or non-relational NoSQL, pretty consistently, most data-oriented workloads, that are have any sort of performance requirement are used in EBS. Now I want to move into the Nitro stuff, which is fascinating. So I mentioned that we basically build our own ASIC chips, right? And we put them on our own, designed cards, right? Interface cards, right? Think of it as like a NIC, right? A network interface card, right? So in a physical server that we build, depending on the size of it, obviously, we have many of these Nitro cards that basically allow us to offload a lot of system processing that happens with respect to networking, with respect to encryption and security, networking, storage. The boot logic is all on these sort of custom cards, so that we can really control everything that happens on this card. And unlike a lot of cloud people running sort of traditional commercial hypervisors, right? We have our own hypervisor. I mentioned it earlier. It's a Zen-based hypervisor, but we've stripped out everything that is general purpose about this and made it very custom to the AWS landscape, right? And so the goal, and I think if you ran benchmarks, you would see to be able to get kind of bare metal performance in what is effectively a containerized environment, right? There's some great resources if you want to read up. We hired this guy from Sun and Microsoft in the old days named James Hamilton. If you search for James Hamilton, he's got a blog site called Perspectives that has some really insightful stuff about how AWS uses our own sort of hardware and ASIC technologies. From a security standpoint, I'm not going to go through all of these, but you know, pretty much wherever you are, whether it's in EMEA, whether it's in Asia, US, we've got compliance and security validations for pretty much everything. I don't think there's anything we're missing at this point. And lots of different techniques and technologies that we use for managing security, right? We have our own key management service, our own certificate manager, our own hardware-based key store. You know, on directory access, we integrate into like AD and Kerberos and all the traditional enterprise things. You don't have to use the cloud-based stuff. We've got, you know, continuous threat detection and monitoring that sort of sits outside people's environments. So pretty much all the building blocks you need to build a really secure, you know, environment here. All right, so let's dig in for the next probably 5-10 minutes on some considerations, right, for running databases, right? So the first thing is, what you will probably notice when you try to lift and shift an existing application into AWS, or probably true for every other cloud vendor, is that you'll get a little bit of cost savings right away, but it's going to take a little bit of trial and error, right, to figure out, you know, the right instance type and the right instance size, right? Because in every case I've seen so far, people moving from on-prem systems into cloud can shrink the size of their compute capacity, right? And it's not just because of elasticity and other things, right? Shutting off QA systems. It's really the fact that in all of these Nitro-based instances, we've offloaded, you know, a lot of CPU cycles onto these Nitro cards. So that frees up a huge amount of cycles, right, for real work, for your guys' applications, databases to run. So the first thing you look to do is to really figure out the right instance size. And then you start looking at how to optimize some of these other areas, right? Networking, you know, storage. Maybe over time you start thinking about actually refactoring things and integrating with other services, and that starts to really drop the sort of cost equations of cloud. So some general tips on the network, right? First of all, network bandwidth is the key. You know, latency is the key, right? So if you've got, you know, databases that talk to have a lot of concurrent connections, you know, thousands, tens of thousands of connections, you're going to want to use these Nitro instances, right? Most of the more modern instance types are Nitro based, but it's really important to get that sort of high level of network bandwidth, low network latency, and high throughput on the storage side. We have super high, what we call elastic fabric adapter instances, EFA. Those are the 100 gigabit instance types. They're not everywhere, so you need to definitely, you know, kind of look through that. The other thing we offer in EC2 is something that we call placement groups, right? And a placement group really helps the hypervisor and the scheduling side of AWS, right, instance scheduling, to determine how close or how far apart two instances might be. So if you've got you know, some app servers and a database server, in some cases you might want to have those co-located as close as possible. In other cases, or you know, maybe in some scenarios, you want to spread them out, right? You want to maybe have more control over placing, you know, some of your app servers in one availability zone, some others in a different availability zone, do some sort of load balancing across them for high availability, right? Rep server is another good example, or IQ, right? You want to make sure that if you're running a multiplex IQ cluster, that you keep those nodes very close together. So defining this placement groups basically allows the EC2 scheduler to basically try to co-locate them, if it can, even in the same rack. So you go to the switch at top of rack and you come back down again. So really very useful tool. The spread placement groups noted at the bottom is where you want to spread these things out across different data centers, different availability zones, to make sure that a failure in one doesn't affect failures in another. In ASE, TDS packet size is still important, right? I know there's a tendency when people move to cloud to think that the cloud is going to handle everything. It's still important because, I mean, really, it's an EC2, it's an ASE optimization anyway. Cross-region traffic needs attention, right? We have this concept of a VPC, a virtual private cloud, which is basically the network configuration. And those exist within a region, but they don't span regions. So if you're doing things that span regions that have to go from US West to US East, there are some techniques you need to do to make sure that both the data doesn't leave the AWS backbone, like over the public internet, and as well as that it's encrypted, right, using SSL or some sort of VPN type technology, right? So super important to pay attention to that. And then we have this direct connect technology to basically allow you to go directly into the AWS backbone, right? So it never touches, data never touches the public internet. On storage, we've talked a little bit already about EBS. That is without a doubt the storage model that most high-performing database applications, whether they're ASE or IQ-based, are going to be using. Right now, our maximums are 80,000 IOPS with about 2.3 gigabits of throughput. That's a per instance. So if you have a cluster that are tied together, that's going to be per cluster. I'm sorry, that's going to be per instance. But if you have volumes, multiple different storage volumes, those limits are slightly lower. So a lot of the exercise, just like we did in the old days, right, of spreading data across spindles and making sure you had enough throughput, you have to consider that as well in at least in the AWS. And as we talked about, those Nitro instances are really key to getting the high performance, right? We do have some instance types that have local storage, right? Local storage is basically ephemeral, and if the instance crashes, whatever's on there is gone. So TempDB makes a lot of sense. We've got some instance types with super high throughput, SSD, and so you want to pay attention to that. And then lastly, make sure you choose the instance types correctly. Hyperthreading is on in the cloud world. There are ways to turn it off. But generally speaking, even ASE is doing okay these days on hyperthreads. So I would be less worried about that. And you have to remember that this is a virtual environment, right? And just like other virtual environments, especially if you have small instances that you're using, we're time sharing those cycles, right? On the physical box, we're time sharing them between different instances, right? So pay attention to that, right? Remember runnable process surge count. It might be helpful if you find that you're, getting a lot of stolen cycles, right? There's a metric in our CloudWatch monitors that we call steal, which is basically the percentage of physical CPU that's used by other virtual machines running on that. So pay attention to that. I think, it's all good. All right, and with that, yeah, so that's pretty much what I wanted to chat about today. AWS, pretty fun place. And with that, I will turn it back over to Ed.
All right, great. Thank you very much, Peter. That was a really very interesting presentation, and love the dark mode on the slides too, by the way. We'll go ahead and start the part of the presentation about Bradmark surveillance. Now, Bradmark surveillance, we're going to be showing a little bit about what that means to monitor on the premises and on the cloud. You know, AWS is a fantastic platform for doing the databases and doing the monitoring for the databases, as well as other cloud platforms such as Azure and IBM Cloud and other ones as well. But AWS, especially for us, has been a really great platform, and Peter really went into some of the great things that AWS is offering in terms of just the variety of options for ASE and for other SAP products, and just in workloads in general, which is really great. So if you've already seen the part 2 of our webinar series, some of this is going to be a little bit of a review real quick. Bradmark, of course, has lots of benefits for monitoring the SAP products or other databases on your premises or in the cloud. We have a lot of different metrics that we're able to look at through a web monitoring interface. We have historical metrics, so even if the database is offline, you can go back and review what was going on yesterday, what was the problem yesterday, what was the problem last week. We also have been getting into a lot of more reports for compliance items. So if you're trying to do things like auditing or tracking other types of bad logins or SQL or anything like that, we have a lot of tools in Bradmark surveillance to look at that kind of stuff. And of course, we also have a lot of unique metrics for more in-depth analysis. When it comes to ASE or to Postgres or MongoDB or a lot of other databases, we have a lot of interesting metrics that help you dive in, deep dive, and find out what's going on with that particular database. So for example, one of the things we've been doing lately is auditing, and you can see some of this type of auditing report for ASE. This is based off of the auditing system in ASE, but we do a lot of work with the data in order to make it in a nice, easy to read format. We have some major features in surveillance, such as time slicing, which is what we also call our recent history, where we can take a look at top SQL for the past yesterday or last week. We can also take a look at top SQL per hour of day. So if you're seeing slowdowns throughout the day, you can see which are the most SQL that's most impactful. We also have our flashback capability, where we can actually take our real-time interface, things like what's currently running, what are the current I/O that's going on. We can take that back in time to 3 o'clock yesterday or 3 o'clock last week. We can also do web reporting, so we can do over long-term trend analysis, and as I mentioned, audit reports and compliance items. We have a lot of security compliance for things like PCI DSS and other types of hardening aspects, which is great for running surveillance in the cloud as well as on premises, and an alerts dashboard, so you can see the red, yellow, green status of servers and databases and things like that. When we deploy Bradmark surveillance, we have our central alert server, or CAS, where people can log into. You can browse to different databases, different servers, get in a central place for alerts, those kinds of things. And then you can also, we also have our satellites, which allow you to see the actual databases and things like that. So it's a very federated kind of system, and the data is also federated between all of this as well. And this is especially important when it comes to the cloud environment, where you may have SATs that are in the cloud, you may have SATs that are on premises, and those kinds of things, which we'll cover in just a moment. Now, surveillance on the cloud, and I'm going to be mentioning a lot about AWS, but a lot of it also applies to Azure, IBM Cloud, and other types of systems as well. For monitoring all the databases from one web client across all your databases in the cloud and on premises, surveillance is a great tool for that. As I mentioned before, the CAS is the central place for people to log into, to browse different databases, that kind of stuff. It's a standalone instance usually in the cloud. We have customers who love to have those surveillance CAS in the cloud, so they're able to have that accessible from anywhere. You can also have an optional reporting server for web reporting, or you can do it on the CAS. Of course, the SATs that are out there that are either in the cloud or on premises do the actual monitoring of the ASEs, or the IQs, the HANAs, the Postgres, the Mongos, those kinds of things. Or you can also you can do that remotely, or you can do that on the same machine as the database. So we have a very flexible system for doing that, and there's different benefits to doing it either way. So everybody logs into the CAS in order to take a look at alerts, be able to browse statistics, things like that. You can assign different permissions so that you can have different people accessing different servers, different databases, different windows, different alerts. So a very fine-grained system for doing that with roles and that kind of stuff. And of course, we have the alerts dashboard that provides a nice single pane of glass for availability, incidents, SLA reports, which we'll see in a moment, and things like that. And you can seamlessly browse all the different places. So whether you have databases in the cloud or you have databases on premises, all that looks the same in terms of monitoring inside surveillance, and provides a nice seamless environment for that. This is the kind of example of the alerts dashboard. So from here we can see red, green, yellow status of different servers, different databases. And this is all coming into one place, so you can have this up in the cloud, have total availability of the alerts dashboard, and then your databases can be scattered through whatever different cloud services. So you can even have this dashboard integrating alerts from systems that are on AWS and Azure and on-premises and all that kind of stuff. And very easy to see, nice single place to go to. And then you can jump directly to investigate further as well. SLA reports are also available, so you can see entity uptimes. You can see here one of my Postgres instances that wasn't quite 100% uptime on here, but you can see this over again over all the instances that you have running in the cloud, on premises, and those kinds of things. So the demo website for Bradmark itself actually is running on AWS, and these are the specs for that particular instance. We actually have several different instances in the demo system. The demo system called demo is actually our CAS, and it's a T2 medium, very, very minimal specs, pretty much, very minimal storage. It doesn't take a whole lot to run our CAS system. We actually overdid it a little bit because we're actually running other things on there. But you have very minimal aspects that you need to set up for the CAS system. And then we have other systems, what we call our demo land and demo sky nodes, that are also SATs. Those are other SATs running in other areas of AWS that we're able to seamlessly browse to see other databases, which we'll see in a moment. And they're all grouped under a particular domain. You can have different domains, just an organizational structure inside the surveillance product. The modest requirements for these two instances, I mean, you can run it on something as small as a T2 micro with certain types of credits, slowest storage possible. Bradmark surveillance itself doesn't require a whole lot. So it can be, you have the flexibility of deploying it either on standalone instances or along with your database on a particular EC2 instance. But the total requirements, of course, depend on the number of entities or databases that we're monitoring from that particular satellite, or the number of stores that are turned on. That impacts the storage requirements, and there's other types of things that might impact it as well. But definitely flexible to handle whatever you might be having in your environment. Security, of course, is a very important aspect of this. You can put surveillance on the same VPC or a different one. As Peter was mentioning, you have the VPC networks that are out there. Surveillance can work very well with different types of VPC configurations. But even if you're on the same VPC, we do recommend turning on TLS for our SAM-to-SAM communication or our SAT-to-SAT communications, so provide the greatest security. And of course, if you're monitoring the databases remotely, for example, then you definitely want to turn on TLS or any other types of encryptions that are available just for the database as well. So whether you're connecting directly, let's say it's local to your VPC and you're going to connect directly there, or even if you're just connecting over the internet with, let's say, like if you're connecting to Oracle with a wallet or something like that, you definitely need to have the encryption available for that. And surveillance, as I mentioned before, also has a lot of great compliance hardening already in it. So even depending on your settings in your environment, we can handle that and still be secure as well. Now, if you're integrating on premises, there's a lot of different reasons you might be integrating on premises databases. Maybe transitional, maybe regulatory issues. Maybe you just want web access to monitoring the on-premises. We have customers who don't even want to install the surveillance in their local environment. They can do that all up in the cloud and still have access to on-premises. Or you may be doing a comparison. Let's say you're migrating to AWS and you want to compare the performance on the on-premises versus the database on AWS. A lot of different reasons to still integrate on-premises with your monitoring. And there are a lot of different ways to do it, and it's really based on the needs that you have. The three big areas of needs are like real-time, recent history, or long-term history. So if you're looking for real-time access, that's going to dictate a certain level of access to the on-premises environment. But if you're only looking for recent history items, like for example, you just need to find out, in a delayed fashion, maybe what was happening yesterday or last week, that would be recent history. If you want to do more long-term history, that would be more on the reporting side. That can be a more delayed item. So depending on your needs, that determines the exact technologies that are used for integrating with on-premises. So for example, and here there are a lot of different ways to do it, but here are a few examples. One way is through Amazon VPN, which is basically an IPsec connection that'll provide you real-time access to the stats that are on premises. And so you can either, or it has access to the on-premises databases. So you could deploy stats that are in the cloud that connect to those on-premises databases through the Amazon VPN. That way you don't have to install any surveillance on the internal network. Some customers like to do that. Or you can just have the surveillance CAS out on the cloud site and then integrate to stats that are running on premises. And then that way it just provides a nice seamless way and anywhere access to the stats that are on premises that can then collect the data locally and those kinds of things. If you're just looking for recent history or long-term history, of course, another option is to actually either ship our local stores if you're just interested in recent history, or to export data to a database on AWS, in which case then we'd have web reporting available up on the cloud instance. And then one other option is, of course, you can always just do it manually and have surveillance installed both on the cloud, on your cloud instances, and on your on-premises, and just have different CASs for each. And you can use the same interface on both of them. So especially if you haven't been able to get to the other technologies yet, you can at least get surveillance going on your cloud and surveillance on your premises, and you can still have the same look, feel, everything's the same between the two. That way, when you do combine them or you transition to the other one, you'll already have people trained on that interface. So briefly, to investigate with surveillance, there's a lot of different things you can do with surveillance that are available in the cloud or on premises. For ASE, we can take a look at recent history and see what's the longest running SQL during a particular time period. Here we see we're investigating a particular SQL, and we're able to get the query plan for that SQL. This is coming from our recent history stuff or our time slicing items. We can load all the different query plans for that SQL during that time period, and we can easily see this in the nice show plan format. We can also take a look at it by hour of the day. So you can see here between noon and 4 in the afternoon, we have a couple SQL that are running a little bit longer. This is a particular blocking scenario, and we can click on that and see more information on that. Or we can take the whole interface back in time with our flashback feature. So if we're looking at what's currently running, this is when we flash back and we can see, okay, these items were running. This was the query plan during that time. And again, this is coming from our recent history data. So we'll go ahead and go into a quick demo. And just switch over to here. So we're actually going to be up on the Bradmark demo site. And I'll go ahead and take a log in. So here we're browsing different SATs that are in our environment. We're on the CAS, and we're browsing the different SATs. We have a demo SAT. We have a demo land. And a demo Sky SAT. And these are all running different databases. Over here on the demo site, we're running ASE, and we have all of our different real-time windows available for ASE. So we can bring up our health window, for example. Of course, we have a lot of different areas that are available, the health, some global statistics, processes that are out there currently running SQL. Here we have an overall health view of what's going on with the disk I/O. We've been having a little bit more activity in the past hour. CPU, at least on disk-wise, we have CPU items. We can see it currently running SQL out here. We actually have a blocking scenario going on. We'll go ahead and bring up the block processes window to see what's going on with the blocking scenario. See, I have a particular SPID that's blocking other SPIDs, and I can click on this to see the particular SQL text for that. I can see the show plan for that. And of course, I can go back over here to our calendar control, and I could actually flash back in time if I want to yesterday at 3 o'clock, for example, and it would show everything again at 3 o'clock yesterday. So all of our stuff is available. This is a cloud instance of ASE that we're connected to, but if it was on-premises, it would be just the same as well. If we integrated with on-premises, then it would show up as just another SAT in the tree here. So here we have, in this case, all these three SATs are actually in the cloud, but if we were connecting to an on-premises SAT, it would show up in the tree just like this. We'd be able to browse to it just like this, no problem at all, and have the single interface to both cloud instances and on-premises as well. And you can see here some of the other things that we are connecting to in the cloud environment. We have a SQL Server environment that we're connecting to over here. This is running in a Windows environment on AWS. So our original environment here, the CAS, is actually a Linux box that we're connected to. And then over here is a Windows environment that's running on AWS as well. It has a SQL Server. And then we also have an Oracle environment out here going as well. So a very nice way to seamlessly go to different instances and see a whole lot of different statistics available for each one. As you can see, the full environment of ASE statistics is available, just like we had on premises. And then in addition to that, we have things like recent history. So if I wanted to go investigate, for example, the top SQL in the past 24 hours, I could go over to recent history and take a look at this and see what's going on in the last 24 hours. And you can see here in the last 24 hours, most of the time that's been spent by any query has been one of my blocked queries. And I can load plans for that particular query during this time period of the last 24 hours. And here's the only query plan that's been going on in the last 24 hours in a nice SP show plan format. This is with our recent history information. And of course, if we want to, we can also go and take a look at longer term history with our web reporting. And we could go and take a look at ASE reports and SQL Server reports and those kinds of things as well. So no matter how, what kind of level of integration you have with on-premises and with the cloud, you have a lot of different ways of getting at information, either real-time, recent history, or longer-term history. And we also have alerting capability, an alerts dashboard for everything that we've been looking at now. So you can see here we have a lot of things going on right now. You can see the blocking scenario going on from ASE. We have some long-running things on SQL Server going on right now. So this is spanning, again, the cloud environment, the on-premises environment. We can take a look at it by servers. We can take a look at it by databases. So you can see I've had quite a few problems recently going on in the last hour or so. But here again is the ASE items. And if I want to drill down to that, whether it's in the cloud or on-premises, I can go ahead and just say I want to look at this particular item. I can say I want to drill down to it, and it takes me directly to the window we saw earlier where I can take a look at the SQL plans, and those kinds of things. So a great way to integrate on-premises and cloud and be able to monitor all of that with one particular interface throughout. So I'll go ahead and go back to the presentation. And we'll just, we're running out of time, so we'll go ahead and skip some of the items. We have a few more information about more detailed investigation that you can do with surveillance. But you can try this yourself. If you want to go to our demo site, there's the URL for it. It's on a particular port though, so make a note of that if you're going there. But generally we have activity between 1 and 5 p.m. Eastern. You can take a look at current stuff that's running, but if you're looking at this at a later time, you can use our flashback to easily go back in time and see what was going on if you want to see the post-mortem analysis that you can do. And there's a login information. This is hosted on AWS with very minimal minimal specs on there going on. And as we saw before, this is what it looks like, where you can browse the demo land, and the demo sky systems on there. Okay, so now we've covered a little bit of surveillance. We'll go ahead and go into Q&A. And we'll go ahead and talk with Peter and get some of your questions answered. So first question that came up is, one of the questions that came up was, Peter, does ASE make use of the AWS hypervisor and Annapurna Labs hardware?
So yeah, I mean, first of all, the hypervisor is, kind of a general purpose thing. So no tool really, no whether it's ASE or any other, system really, quote, makes use of it, right? The hypervisor is there just to schedule, instances and things to run on the physical stuff as well. And Annapurna is really just the company that AWS bought a number of years ago that was building all of the ASIC chips and doing a lot of the hardcore semiconductor-based work that now rolls into Nitro.
Okay, great. Another question is the transaction log of a hosted ASE available for replication to on-prem applications?
So yes, you can set up a rep server to replicate from a cloud, kind of instance into an on-prem instance. Obviously, it's going to take a little bit of work. You're going to need to think through the security pieces of it, right? Poke holes and firewalls and do all those sort of things. But it's definitely easy to do that.
Okay, switching gears a little bit, another question that came in is the ASE cloud service available in New Zealand? If not, when is it likely to be available?
So right now, the nearest region we have to New Zealand is Sydney, which is a bit of a haul, but not too bad. Yeah, I'm not sure of plans. I don't know of plans to have a region in New Zealand, although I would love to. New Zealand's one of my favorite spots in the world.
Okay, fair enough. Here's a question that seems popular. Is ASE certified on all Nitro instances?
So yeah, I mean, first of all, SAP certifies ASE really by an operating system version, not necessarily the hardware you run on it. And virtually every Sybase customer that I've worked with here at AWS that is running ASE in AWS is all running on Nitro instances, so yes.
Okay, great. It's a little bit of a complicated question, but basically the gist of it is, you can read it in the Q&A panel, but does AWS allow an HA setup where primary source server hosted ASE is automatically mirrored to a standby ASE and eliminated the rep server process with its own storage and latency?
Why would you ever want to get rid of rep server? Tom, what's behind that question, Mr. Orbeck? So the answer is really probably not what you would want to do, right? You could certainly set up a facility that would allow you to replicate the storage, right, to another node. But that would basically be like a synchronous SRDF type scenario, right? Storage replication where you're just replicating the blocks, and you don't have an active or even a passive ASE that's sitting on the secondary side. So while you could do it, I'm not sure that it makes a lot of sense. We do not have a solution really to provide a standby ASE that is just there waiting, to be filled over to. That's really where rep server and the HA work that the SAP guys have done comes into play.
Okay, great. Is there a test lab where we can install ASE on AWS and try it out? And what versions of ASE are available? Does AWS support?
So yeah, I think we answered this in the chat or in the Q&A, but yeah, there's a free tier in AWS that you can basically go sign up for. There are limits on how big these instances can be and all that sort of stuff, so you have to be a little careful, but you can go ahead and and sign up for that and then deploy software and play around with it. That's what I did when I first joined AWS, to learn about how all this crap actually works.
Okay, here's an interesting question. Is the network pathing to EBS storage dedicated or shared with other customers?
It's so our control plane stuff is kind of split, right? So anything that is internal to the service, so that would be EBS and things like that, is a separate dedicated network from the data plane kind of stuff that that customer workloads are going to run on and communicate back and forth on. So it's not dedicated in the sense that if customer X, is sharing the same network as customer Y, that's would be, there wouldn't be anything called a public network if we had to have dedicated networks point to point for everybody. But we do separate out control plane and data plane kind of stuff, and obviously it's secure and encrypted, so you don't have to worry too much about AWS people sniffing the wire and trying to get some free tips on stock trades.
Oh, that's not good. But the second part of that question is: are there any no concerns for customers choosing EBS versus what they used on premises for storage?
Security concerns?
Or any concerns in general? Maybe in terms of performance.
Yeah, no, I have to say, because of the kind of work that we did on the Nitro side, plus the fact that we've got these storage nodes that are basically piled up with SSDs, and the way we deal with provisioning performance is to basically allocate more or less storage nodes for a given volume to be able to scale up the IOPS. So I mean, some of the other stuff that we're doing, not necessarily with ASE, but some of the stuff we're doing with some of the other technologies, we're doing write IOs cross-country at around 250,000 IOs per second. So I'm pretty sure that we can scale to pretty much any customer's needs.
Okay, that's great. I think that's it for the Q&A. If there are any other questions, please send it on to us, and we'll try to get you an answer from Peter if you have something after the presentation here. So back to you, John.
Not a problem, Ed. Thank you, and obviously, Peter, it's always a pleasure having you on board with us. You've been a presenter with us on many occasions in the past, whether it's Sybase, HANA, or now in the cloud, in the AWS cloud, and they've always been extremely insightful and informative. So thank you so much for that.
Very welcome.
Absolutely. Well, listen, everyone, we will continue to host these presentations moving forward, and again, as they become available, I'd like to again thank everyone and our partners, SAP, obviously AWS, our ISUG tech partners for helping promote our event. We look forward to doing, like I said, future events moving forward as they become available. I'd like to also thank our earlier presenters, Rob Rashore and Chris Baker, who also presented some great insight into the SAP Sybase database, to the SAP Sybase community. So again, thanks again so much, and again, continue to be safe, and we look forward to seeing you soon.
Thank you.